Our final piece of today's lecture will let us start to put together some of this together to figure out how we come up with the formulas for compounds. So while we do this, you're going to want to have a copy of this page and of something like this in front of you, because we're going to be referring back to the charges that each of these atoms form. So let's start out with an example. Let's say that we wanted to make a compound that contains sodium and chlorine. So we need to determine how many of each element do we need, and finally we're then going to figure out what we would name that compound. So sodium, being one of the alkali metals, we find it in group 1, generally forms a +1 cation. Chlorine, as a group 17 element, generally forms a -1 charge. Given that these two have the same charge, or have the same magnitude of charge but opposite signs, one is +1, one is -1, in order for these to be equal, we need one of each. And so our formula here would be 1 sodium and 1 chlorine, so NaCl. Now if we then want to name the compound, naming for ionic compounds is actually usually very straightforward. All we do is we give the name of the cation, which is in this case sodium, and then for the anion we change the ending. And the way that we change the ending is by changing the ending to IDE. So chlorine becomes chloride. So this compound is named sodium chloride. All right, let's do another one. Calcium and fluorine. We find calcium in group 2. That means it gets a +2 charge. Although if we're writing that as an ion, we actually write that in the opposite order. So calcium ion would be written as 2+ as a superscript. Fluorine has a charge of -1. So in order to get to an overall charge of 0, we need 1 calcium and 2 fluorines. And we'd name this compound calcium fluoride. All right, let's do a couple more. How about aluminum and oxygen? So take maybe a minute here and see if you can figure this one out. All right, what do we find? So aluminum is in group 13. Group 13 elements will often have a +3 charge. Oxygen in group 16 has a -2 charge. In order to make those the charges equal, 2 aluminums give us a total charge of +6, which could be equaled out by a -6 from 3 oxygens. notice in some ways the aluminum has a +3 charge, so the 3 is the number we need for oxygen. Oxygen has a charge of 2, and so we needed 2 aluminums. And we would name this as aluminum oxide. Now, what do we do with the metals? So now let's say we are going to make a compound from iron and oxygen. Well, we know iron can be +2 or +3, whereas oxygen is always -2. So now there's not one compound that we can make from iron and oxygen, there's actually 2 different ones. So if we have iron that's +2, then we would need 1 iron and 1 oxygen. But if we have iron that's +3, it's going to be like our above example with aluminum, and we would need 2 irons and 3 oxygens. Now both of these would be named iron oxide, but clearly that doesn't distinguish between them because these molecules have different numbers of irons and different numbers of oxygen. So when we're giving these a name, we also need to specify what the charge is in the name. So if we have iron that's +2, then after we name the iron, we put the Roman numeral 2 in parentheses. If it's +3, we put a Roman numeral 3. So the first compound would be iron 2 oxide, and the second compound would be iron 3 oxide. So from here, what you're going to want to do now is open up in-class exercise number 4, labeled ionic compounds. Right now, I want you to skip the first column on table 1, the one labeled number of valence electrons. That's something we'll cover later on in this course. So you're going to skip that column right now, but you should be able to do the others. And from there, I want you to work on questions 1, 2, 3, and 4. The 5th question deals with polyatomic ions, and polyatomic ions are where we will start our next class. So that ends our lectures for today, March 16th or March 17th. And as always, be in touch if you have any questions.